All right, I'm going to try and do another example of chain rule with you. So I've already written the problem on the screen, and I like the f of u notation. So I would probably rewrite this, that I'm going to find f of u, which is u cubed, which means I'm defining u as 3x squared minus 2 all over 2x plus 3. So the derivative of f of u is 3u squared times derivative of u. But to do the derivative of u, I am going to have to use a quotient rule on that stuff. So now I'm going to actually put in the x's back in. So it's f prime of x equals 3 parentheses, the equation that I defined as u, or that I let u be, I should say, times the derivative of u, which is low d high minus high d low all over low squared. Now we get to attempt to simplify this sum. So I'm going to keep this 3, keep the first parentheses, and start simplifying the back half of that problem. So 12x plus x squared plus 18x minus 6x squared plus 4 all over low squared still. Now, what we've talked about in class is that our book and the AP world, I guess, always wants us to try and write everything as simplified factor as possible. So do you notice on this fraction on the second half, all of those numbers are divisible by 2, which means I'm going to factor out a 2 and I'm going to put it in the front. Okay, so now I'm going to move that 2 out here and combine it with the 3. So that 3 is still part of the original problem. And then when I divide all that stuff by 2, I probably should have combined like terms first too. I didn't think about that. But I can divide all these by 2 and say this is 6x squared plus 9x minus 3x squared plus 2 all over 2x plus 3 squared. Now I probably should combine like terms, right? This becomes 6, 3x squared minus 2 all over 2x plus 3. And then, what do I have here? 3x squared plus 9x plus 2 all over 2x plus 3 squared. And that, we can stop and say answer. As we look at this problem, I want to use this as an example so you can see the difference between what I wrote versus this problem. So what I wrote, it is only the parentheses being squared. So if you would rather write this as y equals cosine of 1 minus 2x squared, then that might help you identify that in this case, your u, or your inside function, is 1 minus 2x squared. So you're doing the derivative of cosine. So y prime equals negative sine evaluated at the inside stuff times the derivative of the inside stuff, which is all of that, which is another chain rule inside of it. So you have to do a power rule, evaluated at the inside, reduce 1 to the power, times the derivative of that inside stuff, which would be negative 2. Now as we go and we want to combine like terms and simplify, I can multiply negative 2 times 2 times that negative sign. So that'll give me y prime equals positive 4 And then I would probably write that piece next as 1 minus 2x times the sine of 1 minus 2x squared. And our final example, find the equation of the tangent line at a given point. So I give us the equation that we want to find, the equation of the tangent line of at the point pi over 4, comma 2. So friendly reminder, when you see tangent cubed of x, that is the fancy mathematical way of saying that's really tangent of x cubed. So what you might want to do is think of this as 2 times tangent of x cubed. Now, let's take the derivative. So y prime equals, 2 is just a constant multiplier. Power rule, 3, keep tangent of x, squared for power rule, times the derivative of tangent. Remember my little psst saying? This would give you secant squared of x. Okay, now if I want to write the equation of the tangent line through the point pi over 4, comma 2, I need to know what y prime of pi over 4 is. That will give me the slope of my tangent line. So 6 tangent of pi over 4 squared times secant squared of pi over 4. Wait, I'm going to change how I wrote that. Let's not write it that way. Let's write it as the other power way. Let's make this secant of pi over 4 squared. All right, do you know what tangent of pi over 4 is? It's 1 squared times, and then secant, well, secant is 1 over cosine of pi over 4, which is 1 over, and cosine of pi over 4 is root 2 over 2. So multiply by the reciprocal, you get 2 over root 2. Okay, so I'm actually going to keep it as that. I'm not going to rationalize it right now. So this becomes 2 over square root 2 squared. And the reason I didn't rationalize it is because I know I get to square it. So let's simplify. This is 6 times 1 times 4, because I'm squaring the numerator, over 2, which gives me 12. I now know the slope of my tangent line. So y prime at pi over 4 equals 12. Can I now write the equation for my tangent line? Y minus, my y value was 2, equals, my slope is 12, and then x minus pi over 4. And of course, I always like to rewrite it. I'm going to add the 2 over, and y equals 12x minus 3 pi plus 2. And I think I'll just leave it like that.